All right, we have an interesting formula to go over here today. Up top on the board, we have this quadratic congruence, x squared congruent to a mod p. P is going to be a prime number, but we're going to want it in the form of something 3 mod 4 that we can write like this over here. And then what we want to show for it is this is going to have exactly two solutions, and they're going to be in this form right here. So in this case, this is the easiest case. When p is 3 mod 4, we can go right to a solution just using this here. Before we get into it, I'll point out a few other things. The main three cases, I mean, there are some different ways you could look at it, but usually we'll look at this as p 3 mod 4. We have a formula for that. There's also a formula when p is 5 mod 8. So we would look at that like 8n plus 5. So for that case, we also have a formula, well, kind of two formulas, and it's a little more complicated, but not bad. The hardest case, or when things get kind of complicated, is this 1 mod 8 case. This is the case when you would use Tonelli-Shanks algorithm or some other complicated method in order to get a solution. One other thing I should point out, though, is for small numbers, you might just guess and check. I basically don't even really want to mention that, but it's kind of obvious that if you have something, I mean, like if you had something crazy, like if you had, I don't know, like 1 mod 7, then obviously the solutions are going to be plus or minus 1. I just do that because there's always someone in the comments that'll say, you could have just done this. And, you know, of course, everyone knows you could have just done this, but the whole point of it is to try to understand it, not just guess and check. So for our case here, for 3 mod 4, so for a real simple example of that, where you could guess and check, like something like x squared congruent to 2 mod 7, let's say, because 7 is 3 mod 4. One thing that won't work is something like this. The reason is because you need this a value to be a quadratic congruence for this formula to actually work. So 2 is, so if we put our 2 back, what we could do is we could look at the Legendre symbol. This thing here is just going to say basically this, is 2 a quadratic residue mod 7? And yes, it is. For the Legendre symbol, we would give this a value of 1. So like real quick, the value here would be when x is plus or minus 3, because if we square 3, that's going to be congruent to 9, but mod 7, that's going to be congruent to 2 mod 7. So we do need that condition that a needs to be a quadratic residue mod p, or else there's going to be no solutions to this. But that's going to be our starting point over here, because what that means is with the Legendre symbol, a over p is going to be just equal to 1. The reason for doing that is because then we can use Euler's criterion, which shows us that a to the p minus 1 over 2 is just going to be the same as this value. So this is going to be congruent to 1 mod p. Next, what we can do with this is we can put everything in terms of n. We know what our p value is, so we can use that here. For p minus 1 over 2, we can just plug in. So we'll have this becomes 4n plus 3 minus 1 all over 2. That's going to be 4n plus 2 over 2, or just 2n plus 1. So what we have over here is going to be a to the 2n plus 1 is going to be congruent to 1 mod 4n plus 3 now. Then from here, what if I just multiply by a on both sides? So then on the left, exponent properties, we're going to have this becomes 2n plus 2. And then I can simplify that and write it like, let's write this as a to the n plus 1 all squared. And then we multiplied in an a on the right side, so this is going to be congruent to a mod 4n plus 3. But now I think we can kind of put this all together, just get rid of this because it doesn't really help us. Our equation back here, what we were looking for is x squared congruent to a mod p, which is just this. So we can look at these two equations side by side. Looking at it this way, we have an obvious solution that x, if we just plug in a to the n plus 1, that's going to give us a, and that's going to be a solution. So what we have here is x is going to be congruent to a to the n plus 1 mod p. And actually, because we're squaring it, I should say that this is congruent to plus or minus a to the n plus 1 mod p. Now all I want to do to finish it is let's just get this all back to p. I mean, we could use this as a formula, but let's get it back to p using our original formula. So working with this right here, I can subtract 3 on both sides. So we have 4n equals p minus 3, or n equals p minus 3 over 4. So coming here, what's going to happen? Plug this in here. So we're going to have a to the p minus 3 over 4 plus 1. But let's do it as a common denominator. So I'll write it as 4 over 4 mod p. Simplify that, and what we get is x is going to be congruent to plus or minus a p plus 1 over 4 mod p, and that's going to be the formula we wanted to show right there, same as this. All right, there you go. That's it for today. Thanks everyone for watching. Have a good day.